All right, welcome back. So we're going to talk now about section 8.2, which has to deal with series. Okay, so series, well, they're very related to sequences, and I'll be honest, I often get the names mixed up, although less now that I've been doing it for a while. But it is very easy to get the names mixed up. Okay, sorry, let me get my lighting right here. Okay, so let's start. We're going to start by saying, okay, let's a sub n be a sequence. Okay, and series are also very much like infinite sums. Okay, one can form the series, the sum of over n of a sub n. Okay, now this is what is this supposed to mean? Well, we could write this as, we should write this. We don't, not, I shouldn't say should, but if I want to give a little more information, I write it like this, which is the limit as some capital N goes to infinity, sum n goes from 1 to n of a sub n. Okay? And so this series may or may not converge, but the series refers to the infinite sum. Okay? So let's do a quick example. We've got our arithmetic sequence. Or I'm sorry, arithmetic series. Okay, we won't spend too much time on this series because it's not really interesting. Okay, because why? Well, the arithmetic series, let's say we have our basic one. K goes from 1 to infinity, or sorry, let's write it. N goes from 1 to infinity of n. Actually, let me go back to K there. You'll see why in a second. So this is equal to the limit n goes to infinity, k goes from 1 to n of k. Now, this thing, you may or may not remember, we have a way to find the sum, right? We know that there's a closed formula for that. Okay, you see it a couple times. You add up 1 through n. Let's do it again. Let's add up 1 through n, but backwards. Okay, these add up, they all add up to n minus 1. I'm sorry, n plus 1, and there's n of them. So this is equal to n times n minus 1. Well, we have the summation here twice, so this sum is the limit as n goes to infinity of n times n minus 1 over 2. That actually is interesting, but now we're getting to the uninteresting part. Because as n goes to infinity, this is going to go to infinity. So, eh, it's what we call divergent, right? We've talked about that as far as integrals and also sequences. Okay, this is an example of sort of the most basic way to look at series and their divergence. So the very first thing, given a series of, let's just say, positive numbers for now, Okay, then let me write it like this. So this is our series. Okay, if limit as n goes to infinity of a sub n is not equal to 0, then it's going to be divergent. See, so this is not super interesting, okay? Every one of these terms, we're adding on ever bigger things, right? Okay, but sort of a similar example. Let's take the sum. It's an ugly summation sign. There we go. K goes from 1 to infinity. K times k plus 2 over k plus 3 squared. Okay, so a sub k equals k times k plus 2 over k plus 3 squared. So, since the limit of a sub k equals 1, okay, therefore, the series diverges. Now, I'll tell you something. You will go online and look up stuff, and you will see something like this. And this is not proper mathematics, so let me... Mathematics. So, but if you go online, you will see someone invariably write something down like this. Okay? And this is not proper mathematics, but there is something there to be studied. Mysterious. Okay? But when you see this, if you go in there, just know I don't think that the people that normally talk about this know what they're talking about in the same way that they should. But there is something there. Okay? There are people that have given this summation this meaning, and it makes sense in that world. Okay? All right, but that's more advanced math. All right, I'll see you in the next video.